Deep in the freezing darkness between the stars, something strange may be drifting through our galaxy. Not stars. Not asteroids. Not ordinary planets orbiting a sun. Entire worlds, wandering alone. These are called rogue planets, planetary mass objects that were either thrown out of their original solar systems or formed in isolation from the beginning. And the more astronomers search for them, the more it appears that our galaxy may be filled with these cosmic orphans. For decades, planets were imagined as objects that naturally belonged to a star. A solar system formed from a rotating disk of gas and dust. Planets grew inside it, and most remained gravitationally attached to their parent star. But that picture may be incomplete. Because planetary systems can be violent places. When giant planets interact gravitationally, one world can steal energy from another. A close encounter can accelerate a planet so dramatically that it escapes the gravitational grip of its star forever. One moment, it belongs to a solar system. The next, it is traveling through interstellar space. And this is where the mystery becomes even more fascinating. A rogue planet receives almost no light from a nearby star. Its surface can become unimaginably cold, making it extremely difficult to see with ordinary telescopes. But cold does not mean invisible. A planet that formed with internal heat can continue glowing faintly in infrared wavelengths long after it has been expelled from its planetary system. Modern infrared observatories can search for these incredibly weak thermal signatures, the tiny amount of heat radiating from worlds hidden against the darkness of space. It is like trying to find a dying ember floating through a frozen ocean. And some of the discoveries are forcing astronomers to rethink just how common these wandering worlds might be. Even more intriguing are possible rogue planetary systems that don't appear completely alone. Astronomers have found evidence for free-floating planetary mass objects that may exist in pairs. If such pairs truly formed together and remained gravitationally bound while drifting through interstellar space, that would be extraordinary. Because an ejection powerful enough to remove a planet from its star could easily disrupt a smaller companion. Yet in some scenarios, a planet and its moon, or even two planetary mass objects, could survive the chaos. That possibility changes the story. It would mean planetary systems aren't simply being destroyed during ejection. Some pieces of them may be escaping together. Imagine a giant planet being thrown out of its solar system while a smaller companion remains locked in orbit around it. For billions of years, those worlds could continue traveling through the galaxy with no star to illuminate them. Their only energy might come from internal heat, radioactive decay, and perhaps tidal interactions between companions. A miniature planetary system wandering through the darkness. And if these objects are as numerous as some estimates suggest, then the space between stars isn't nearly as empty as it appears. Our galaxy contains hundreds of billions of stars, but between those stars could exist an enormous hidden population of planets that emit almost no visible light. They don't announce themselves with brilliant reflections. They don't necessarily transit a star. They don't always have a bright host whose gravity gives astronomers an obvious clue. But even this may not be the end of the story. Because there is another possibility that pushes the idea of wandering worlds even further. Some rogue planets may not be entirely alone in the way we imagine. They could be carrying hidden companions that are even harder to detect than the planets themselves. Subtle gravitational partners. Tiny captured objects. Or debris fields left over from the violent moment of ejection. In the cold silence of interstellar space, these remnants would not disperse quickly. With no nearby star to strip them away, they could remain bound for extraordinary lengths of time. This means that a rogue planet might not just be a single object drifting through darkness. It could be the center of a miniature, invisible system. A system without light. without warmth from a star, but still governed by the same gravitational rules that shape everything in the universe. And if that is true, then the concept of a planet itself begins to blur. Where does a planet end and a system begin? Is a rogue world still just a planet if it carries moons, rings, or captured debris? Or does it become something more complex, something closer to a self-contained planetary ecosystem drifting through the galaxy? These questions are not just philosophical. They affect how we search for these objects and how we interpret the faint signals they produce. Because every additional layer of structure makes detection more difficult, but also more informative. A single isolated planet tells one story. A planet with companions tells another. And a system of wandering bodies tells an entirely different story about the violence and complexity of planetary formation. Future telescopes may eventually be sensitive enough to detect not just rogue planets themselves, but the subtle signatures of their hidden structures. Variations in infrared light, tiny gravitational disturbances, or repeated microlensing events caused by multiple objects passing in sequence. Each of these signals would be a clue, a fragment of a much larger hidden population. And as our detection methods improve, the galaxy may begin to look less like a collection of isolated stars and more like a layered structure filled with unseen mass, stars at the surface, planets in orbit, and beneath it all, a deep background population of wandering worlds. Some of them ancient, some of them newly ejected, some still carrying the scars of their violent origins, and perhaps some still evolving in ways we do not yet understand. Because even without a star, a planet is not necessarily a dead world. Internal heat can persist. Geological activity can continue. And in rare cases, subsurface oceans might remain liquid for billions of years, protected beneath thick layers of ice. In such environments, chemistry could still unfold. Energy sources could still exist. And the conditions for complexity might not be entirely absent. This does not mean rogue planets are likely to host life. But it does mean they are not automatically lifeless in the simplest sense. They are dynamic objects, shaped by forces that do not depend on starlight alone. And that realization changes how we think about habitability itself. Perhaps habitability is not tied exclusively to distance from a star. Perhaps it is tied to energy, stability, and time. If that is true, then rogue planets expand the boundaries of what we consider possible environments in the universe. They force us to rethink where worlds can exist. Not just in the bright regions around stars, but also in the vast, dark spaces between them. And as we continue to search, one thing becomes increasingly clear. We are only beginning to map the true structure of the galaxy. What we see in visible light is only a thin layer of a much deeper reality. Beneath that layer lies a hidden population of planets that do not announce themselves with light or color. They reveal themselves only through subtle effects, brief distortions, and faint traces of heat. And yet, they may be among the most common planetary objects in the galaxy. Silent. Invisible. But everywhere. Waiting to be discovered. They simply move through the darkness. This has profound implications for how planetary systems form and evolve. The traditional picture suggests that planets are primarily products of orderly disks surrounding young stars. But if enormous numbers of planets can be violently expelled, then planetary systems may also be laboratories of gravitational chaos. Worlds can migrate. Orbits can become unstable. Planets can collide. And some can be launched into interstellar space. The galaxy may therefore contain not only countless solar systems, but also the remains of countless systems that no longer exist. Every rogue planet could be a fossil from a planetary system's violent past. A frozen record of gravitational encounters that happened billions of years ago. And infrared astronomy is giving us a way to search for those fossils. The challenge is enormous. These worlds are faint, distant, and often extremely cold. But as telescopes become more sensitive, astronomers are beginning to explore a population that was almost completely invisible to previous generations. And there is one final possibility that makes the mystery even deeper.